Yeah. Check, check. Yeah. Raising it. Close mine. I need to clean my nose before I actually can start. Because like every year, I got a cold. I guess that's winter or something. So, 10:29 and 40 seconds, so I'm starting right on time. Welcome, everybody. I'm Thorsten Lehmhus. Who am I, in case you don't know me? I'm from Germany. I'm actually working for a publishing company. It's called HiC. We're doing still a paper magazine. It's called CT. And I'm having a column there that's called Kernel Log, and it regularly talks about what's happening in the Linux kernel. The texts also go online. Obviously, they're German until maybe some of you still remember until a few years ago they got published on DH in English, but that closed down in 2013. I was actually also a long-time Fedora contributor, or to be more precise, I actually contributed to Fedora a lot 10 years ago. These days I'm doing not that much anymore. Actually, the most important thing, I guess, or what most people know me these days for is a package repository where I'm doing kernel vanilla builds for Fedora, so you can grab RPMs there with the latest mainline kernel or the latest stable kernel without additional patches, and you can try to check if a new kernel makes something better, or if some problem you see is actually from the patches that are part of the Fedora kernel. Yeah. What I'm not is a Linux kernel developer, but thanks to my work is actually I'm having a really good overview what's happening, actually sometimes even better than a lot of kernel developers, because I look everywhere a little bit and don't have to focus on one area. What I actually did for the Linux kernel is working as a regression tracker a little while ago to actually compile a list of what regressions or bugs there were to help getting them fixed in time before a new release. What also helps to get an overview what's happening is lwn.net, because it's a great resource. They're writing really, really good articles about what's happening in the kernel. So what is this talk about? Actually, there are 5 parts. There's a short status overview. Then we get a bit into recent developments. Then we're looking at the last kernel, the next kernel. And then we go over to important changes, looking back a bit to the last 12 or 18 months, what important things changed there. Then I'm trying to actually look ahead a bit. And yeah, then I'm taking a different view of at the kernel, like what's happening in the development, is everything working fine in the last part, in the meta view. By the way, the slides will continue to change this frequently, so better write questions down to not, if you have any, then we can go to them at the end of the session, if there's time. I have a lot of slides, but I'll try to have some time for questions. So, the first part, current status, what's it? Everything works as usual. Current kernel version is Linux 4.9, was released in mid-December, and actually got submitted as regular update to Fedora 25 and 24. So if you're using those versions, you're running a quite up-to-date kernel with the latest features, some of which I'll mention in a few minutes. One of those things this kernel has is it brought support for 500 more devices or device classes. 150 to 200 of them are ACPI, USB, or PCIe devices. So this kernel, as every new kernel, really made the hardware support better and makes sure Linux and Fedora runs well on latest hardware. Especially, I have a quite new laptop. There it's really important to get, often to have latest Linux kernel, because all the drivers are in there, and these new drivers make those new laptops often run way better. What else is happening currently in the kernel? 4.9 made the system and the Linux kernel more secure. That's something that's a trend in recent releases, that there are lots of things happening, lots of small improvements to make sure the system is more reliable and that attackers cannot get into your system so easily. There's really a lot happening there to make everything more secure. We get to details in that in a minute. So, current status 4.9, as I said, was released in mid-December. That means we are now heading for 4.10. That's developed right now and actually likely to come out on February the 20th, maybe 1 week less, maybe 1 week more. Remains to be seen. That often depends on if there are bugs, and sometimes it depends on if Linus is traveling or things like that. Because every new version is released round about every 10 weeks. As I said, sometimes on 9, sometimes on 11. And that's actually quite predictable. You can actually bet on it if you want. Sometimes you lose if Linus is on holiday for 2 weeks or something. Then sometimes it might be 12 weeks, or if there's a big bug somewhere in the kernel found, then it can take a little bit longer to get a new kernel release finished. But normally it's really 9 or 10 weeks most of the time. All those new versions, as I said, there are new drivers in it. That makes the hardware support better. That means changes, and those actually are quite a bunch of changes in those 9 or 10 weeks. That are 13,000 commits around about every new version from around about 1,500 developers. And those add about 700,000 lines of code every new version. Also a bit gets obviously thrown out or moved around. But in the end, it means the kernel grows by nearly 300,000 lines of code every release. And you can see it here. The kernel gets bigger and bigger. That's from the Git area to 613 on the left. Back then, we were about 7.5 million lines of code roundabout. And now we are getting to 22.5 million lines of code, including documentation, comments, and blank lines. So you can really see the kernel gets bigger and bigger. And actually, all those development is happening quite fast. Take, for example, the development between 4.8 and the first pre-release from 4.9. That happened. There were 13 days, and there were a bit more than 15,000 changes, with close to 700,000 insertions of new lines and 430,000 deletions. That means every 35 seconds there was one change. That's really quick. There's really happening quite a lot of things in the kernel to make sure everything works better and the kernel gets improved. And a lot of people say, hey, that's crazy. How is that working? And actually, that's not a problem at all, because those changes are prepared before a new release and then are simply smashed together. Obviously, there are, in the last minute, sometimes things that need to get adjusted to each other. But really, the speed and all those growths is not a problem. Nothing to worry about. In case you're interested in things like that, every year or year and a half, the Linux Foundation, together with a few people, releases a small report, the Linux kernel development, how fast is it going, who's doing it, and things like that. They have many more details on things like that. If you want to know them, grab it, download. You have to register for it, but it's really insightful how kernel development works. Here, for example, is an analysis from this document. It shows how many people are contributing to new kernel versions and how that changed over time. If you're interested in this, there's also LWNet articles on every new kernel release, which actually looks which people did changes and how many were there. And actually, there are also employer statistics in case anyone wonders how big or not big Red Hat is. Until a few years ago, it used to be on the top in both columns by change set and by change number of changes. These days, Red Hat slowly gets down. Here, for example, in the left column, it's on the second place, and on the right column, it's at the fourth. It's not that Red Hat isn't doing so much anymore. It's more that other companies are doing more. For example, Samsung for embedded things, or media, and Intel to make sure their hardware works well. So that's how it comes that Red Hat got a little bit down. That was part one already. I need to drink often today, otherwise my voice might simply break and I can't say anything anymore. Next up, recent developments, part two. So as I said, Linux 4.9 is the recent version. Three of the most important features this version brought are XFS reflink and deduplication, BPF improvements for tracing, and bottleneck bandwidth and RTT. If you wonder what this is, I'm explaining those a bit more in detail. The XFS enhancements, the reflink support, for example, allows lightweight copies using copy and write. That's, for example, if you copy a file within a file system, you simply say, do it with CP reflink, and then a new metadata entry is generated, but the payload from the file isn't actually duplicated, and that makes it possible to copy really big files within seconds or within matters of parts of a second. And if one of those files is changed, then thanks to copy and write, the other isn't changed. So they're really independent files from each other. And that, for example, can be of interest to duplicate a VM, because you can copy a VM image over, it only takes a second, and start using it, and you don't have to wait like 10 minutes or something like that to get the copy first. Deduplication is another feature that's allowed by this copy and writes support. It's like the copying. It's kind of reverse, like the copying. You can scan your file system manually with a tool and check if there are some areas where the same data is stored, and then the metadata can be adjusted to make sure that they both point to just one of those data blocks, and the others gets deleted, so you can save space like that. It's also interesting, especially for big setups. If you have lots of VMs with similar data, you can reduce your storage load and improve things, because less data has to be cached. Downside of this, both these features are not yet usable. They need a XFS procs version that's still under development. Remains to be seen how long that takes until this is getting finished. And another detail around that, there are more XFS improvements to be are planned. Here's actually a list, like there's scrubbing support and sector data loss reporting and other things. And if some of you are interested in file system and look a little bit closer at this list, you'll see XFS is simply gaining a few features ButterFS and ZFS are famous for. So it for a long time looked like that ButterFS and ZFS are the features, or especially ButterFS in the Linux space is something that will be used as next generation file system, but it looks like XFS might be changed insofar that it's really in a better position to compete with ButterFS, and maybe in the end it will be XFS that we're using as our next gen file system. Remains to be seen. These big changes are actually mainly developed by an Oracle developer. Red Hat developer was also involved. But it's interesting that Oracle is driving mainly these XFS enhancements at the moment. So I need to speed up a little bit. What else? I said something about BPF improvements for tracing. Tracing is like looking at the program or that's running, or the kernel while a program is running, and check what it's doing, what the kernel is doing, to see where the performance gap is, or where it would be important to optimize the program to speed things up. And what's now possible with the Berkeley package filter, that's a BBPF acronym I just used, is time sampling and summarizing stack traces. That's actually a pretty complicated topic, and I won't go into that too much into detail because otherwise we just need to focus on that. The thing is, it makes tracing way easier because in the past you had to do the tracing, analyzing, and then put it up and to some output that's easily consumable by users. And these days you can do it with Linux 4.9 and easier thanks to the new features with a way more simpler script and put it to, for example, to a flame graph. And a flame graph is then something like this, where you see, okay, here this is how the program worked, for example, and how long each function was used. And that's, for example, then sometimes easier to see where this time went and actually, as I said, to optimize the program. In case you wonder, yes, that's finally Linux gets to a point where we have features like dtrace. That is something Solaris was famous for. That makes analyzing performance optimization way more easier. And in case you want to know more about this, there is Brandon Gregg who writes a really good blog articles and develops a set of tools to use these features in the recent kernels to do actually performance monitoring or tracing. And there you get way more details, and actually he gives talks as well. So really, if you are interested in this, go to Google dtrace and Google for dtrace for Linux 2016, then you get to the blog post I just showed you. And it's really some interesting insights how to do tracing these days. And there are also great talks from Brandon on YouTube, where he gives a great overview how to actually do that. What else was in 4.9? There was a bottleneck bandwidth in RTT. That's actually a new TCP control, congestion control algorithm. The kernel already has, I think, 15 or 20 of those. So yes, even one more. But it works a bit differently. Like the others, congestion control, in case you don't know what it is, actually makes sure the bandwidth is used as good as possible to make sure your data is getting from the server to you as quickly as possible, and to reduce congestion where they are fighting, hey, can I go to the wire or do you have to? As I said, it works differently than most others. It was developed by Google mainly. Two of the main features are it improves resilience against random loss. If they are on the wire for some reason, sometimes packages don't make it through, then the speed won't decrease that much. And it avoids some problems that happen due to some bloated buffers that are often common on the last mile, like from your house to the next station where the internet gets together by your provider. It can make things really a lot better, I guess. We actually might use this in Android because it was developed by Google. I guess they want to use it there, but they haven't said anything. Remains to be seen if it gains traction and how much it will be used. What else? I can talk about 4.9 for hours. There were some, for example, some security improvements like virtually mapped kernel stacks. This is the second one here. That makes sure that stack overflows in the kernel are detected and cannot not be used by attackers. Or the last two features here are something that are really important for SE Linux and using for containers because overlay FS is actually used there quite a lot. And the ACL support, access control list for Fuse, is also something for Gluster and Ceph because they use Fuse to get access to the. You can use Fuse to get access to those things you stored on Gluster and Ceph. volumes, and that makes sure only the right people get proper access there. If you're interested in more details, you can read them here in the German version if you want to. I know some people that know my work actually run my German articles through Google Translate, and they say it works quite well sometimes. But if you want straight English, go to lwn.net, and they have an area where they cover the features from 4.9. So that was 4.9. 4.10 is the next one. As I said, it's due to in 3 weeks. I also looked again for 3 important features. One is GPU pass-through, and the other are storage related. It's write-back throttling and write-back cache for RAID 5. I'll explain those more in detail now. A GPU pass-through, I guess most of you will know, it's simply putting your GPU from the host to a VM, or maybe even a container, to actually run games if you're on a Windows VM that's running on Linux. That's actually quite hard to do until now, but there are really some improvements to make things work better. And this GPU pass-through is done with 2 different techniques. That's also the first one is mediated device, MDEV, and the other is Intel GVT and KVM GT. MDEV is something like where your host kernel can grab parts of a hardware or a complete PCI chip and put it securely to a VM. The important part it can do that with parts of a chip, for example, with the GPU, so your graphics core, graphics processor in your device. There you take just, for the Intel case, just parts of the Intel GPU and put them through the VM to make sure the VM can't use this MDEV to get control over the host. And to use MDEV, you need support for in the driver, and that's where KVM GT comes in. That's actually support in the driver to hand parts of the integrated graphics from your Intel processor to a VM. That actually still doesn't work that well yet, pretty rough and work in progress. There's a blog entry from Gerd Hoffmann that explains the current state. He actually showed a window yet where he got kernel output, but it was a bit messy in some places. So it will take a little while before you can start using it. But maybe in the end, it's really will be possible to run Windows games in a VM that's running on a Linux host, because AMD and NVIDIA plan something similar. They plan to use this as well. So maybe for the gamers that want to use Windows, you don't have to dual boot anymore. You can maybe just open your Linux KVM VM and simply use your graphics card there. What else? Write-back throttling, that's a bit a complicated topic. The short version is make background write-back less annoying. And now you might ask, what is background write-back? Hey, what do I care? I guess a lot of you experience this. You try to DD an ISO image to a slow USB key, and for example, in Fedora image to install Fedora. And while this DD was running and transferring the image to the USB key, your system became really, really slow. That was because the Linux kernel was writing this data out to the USB key with, as you can say, maybe with a higher priority, and reads from the disk to, for example, the Firefox user does when you use it, were actually putting a hold, and that's why your system suddenly felt so slow. And that's something the kernel developers finally took a closer look at and hopefully fix this. They actually tried to fix this a few times already. Maybe they did this for real. It's also important for your databases or something on your servers, and because something like that obviously can lead to long latencies, and that's what you don't want, because your database doesn't reply or to connections or in time. So that's hopefully going to get better there. What else? For the sysadmins here, maybe of interest might be the write-back cache for RAID 5. That's actually where you have a RAID 5 array and put an additional disk to that RAID 5 array, typically SSD, to improve the data. Until now, that was actually, this is called a lock device. And support for this was added in 4.4. Until now, that was actually only used to make your system more secure, to make sure all the data made it to disk, even if the system crashes at some time. That avoided, for example, the write hole. But now it actually can be used as cache. And that makes sure that that more writes are accumulated and then written in one go, and that reduces the time to read, modify, write cycles. And in the end, it means better performance for RAID 5. And as I said, you need you don't get it for free. You need a caching device attached to it. What else? 4.10, just like 4.9, brings a lot of features. For example, the Nouveau driver for NVIDIA cards, the open source driver, got a little bit better. For example, it's supposed to get 4K displays running properly now. There's Turbo Boost Max 3.0 support to make sure your Intel CPU gets as quick as possible to the quickest frequency level, and actually a new technique to get to talk to your CPU how it's using the caches, the first and second level and third level caches. Actually, that can be important in high level setups to make sure the performance is better. But as I said, it's pretty specific. If you want to read more about it, LWN has articles, and I'm writing on it on my German article as well, but I haven't written about that yet because 4.10 is not out yet. Yeah, that was part 2. I guess I need something for my throat. Wait a moment. Some magic. So, important changes last 12 to 18 months. As I said earlier already, kernel self-protection, kernel hardening to improve the security, because kernel developers and outsiders noticed more security bugs just happen. And some analysts showed it takes often about 5 years until they are found. So it the kernel developers came to the conclusion they need to protect the kernel a bit better against common flaws. Sorry. And that's why they are integrating these hardening techniques, security techniques, just like cars are prepared for potential crash these days. That's pretty normal, and it wasn't like that in the 50s or 60s. This work is mainly driven by the kernel self-protection project that was actually founded like 1.5 years ago, I think. And they improved and merged really a big bunch of security and hardening techniques in the past year. Here's a list. I won't go into detail. As you can see, there's 6 or 7 things, and that was just what was in 4.8 to make the security better. So really, there's happening quite a lot. There were similar new features in all recent kernels and the 4.10 as well. And yeah, there's more to come. And if you're wondering, hey, is the security making my system slower? And to be honest, yes, that sometimes can happen, that the system gets a bit slower due to the security measurements. but normally the kernel developers make sure the performance impact is not too big. It's a bit like with cars. Those get a bit heavier due to protection techniques as well, but we accept that today. That's pretty normal, and because if there's a crash, our lives are more important than a little bit speed or something on the road. If you want to get details about this, there are slides from the security summits. There's here, for example, from Keith Cooks, something that's the state of the kernel self-protection project, a talk that was given last fall. If you want overview why this protection is needed and what kernel developers are doing, go and watch that video. It's like 45 minutes well spent. What else? The graphics drivers in the kernel improved quite a lot. Actually, in case you don't know, the most important part of your graphics driver stack in your Linux system actually is a kernel driver, and the kernel driver is really important to get the best out of your system. And the user-land drivers that are working together with the kernel drivers also improved quite a lot. That's worth its own talk. In case you wonder, you only get a quick mention here now. And as I said, some of the things I mentioned are in the user-land parts as well. We have 3 major vendors for graphics processors on the desktop. That's, for example, Intel. And the most important thing that's happening there right now is we finally got to OpenGL 4.5 support in Mesa 13.0. That was like 3 months ago. So most of the up-to-date games should simply work these days. And one more word on Intel graphics. They have a good reputation in Linux, but sometimes they are not that good as their reputation. Skylake supports, for example, the Core E6000 series. The support in the beginning wasn't that good, but it works quite well most of the time. Where really a lot happened in the past 2 or 3 years is AMD Radeon drivers. The open source drivers improved really much in that time frame. You have to really say thanks AMD for that. Most things simply just work these days. That includes video acceleration, high DPI things, and other things. And the 3D performance is also quite good. It's not perfect, but it actually got closer to AMD proprietary drivers, and actually sometimes it's better. And Mesa 17.0, which is due to in the next few weeks, will actually bring official OpenGL 4.5 support, and that's important to get the latest games running. So it will make things a lot better for drivers. There, for AMD, the reputation for the driver is not that good. They are actually better, but not everything is perfect. For example, in the latest cards, you can't do audio via DisplayPort or HDMI and things like that. There's a bit, as I said, also a bit complicated topic and worth its own talk. Next up, NVIDIA is the 3rd major vendor. As you might know, the free and open source drivers are quite slow and lacking features, but they are improved all the time as well, and they are sometimes good enough these days for things as well. Actually, NVIDIA since 2 years now participates a little in the Nouveau development, but it didn't make things much better. A big problem there is that 3D acceleration requires assigned firmware these days for the 900 and 1000 series. It took more than a year for the 900 series to NVIDIA to release this firmware. Support was merged in 4.6 and is finally usable these days. For the latest series, like 1070 and 1080, support was merged in 4.8, but NVIDIA still didn't release the firmware. That's really annoying. Yeah. So, what else? ButterFS. There were lots of fixes and few small improvements in the past 12, 18 months, but no big changes recently. So as I said earlier already, ButterFS was supposed to be the next generation file system for Linux, which everybody would be using. That was actually how it was told, or how it made the media when ButterFS was introduced in 2008, 2009. And you might wonder, is it finally stable? It's also a complicated question, not easy to answer. In case you wonder, it's a bit like, can I swim here? The answer depends on the local conditions and your swimming abilities. Yeah, I actually have 3 pictures. I mean, most of us can swim here, and even kids, you would feel safe to get your kids swimming here. But I mean, you can drown here. That's like every file system can eat your data if you're doing something stupid. And but for comparison, that's a bit like X4 these days. It simply works. ButterFS, I'd put this picture. I mean, it looks a little bit more dangerous, but I go swim there. I'd be careful with the stones there, but I guess you can swim there if you know what you're doing. But you wouldn't let your kids swim here without overseeing them. The problem with ButterFS is there are sometimes areas where that are a bit more dangerous, because some parts of ButterFS are still work in progress and unstable. And the most important thing is RAID 5 and 6 support, which is included in ButterFS directly. It's known to be unfinished, and I think that's not the only feature which is unfinished. Luckily, we now have a table in the ButterFS wiki that explains which features are considered stable and which are still unfinished, and RAID 5 and 6 is one of them. In the end, ButterFS, the message I want to give here is ButterFS requires some time to learn due to things like that. And that's only worth it if you benefit from ButterFS features. If you're interested, look in it. If there's something like the snapshot support, like OpenSUSE uses and relies on, that's worth going for ButterFS, then do it and expect some time to learn. And then it is worth the trouble, but not to simply use X4 or the XFS if you want to. What else? The Raspberry Pi support got better. You can boot the recent kernels directly on the Raspberry, for example. And there are actually graphics drivers for the Raspberry Pi now open source in the kernel and in Mesa. And that makes it possible to run Fedora 25 simply on the Raspberry now, because you don't need anything that Fedora can't ship. So it's way important, to makes Fedora run way better on the Raspberry. What else? There's a lot of other things I could talk about it. I'm running out of time because I thought I had till 20.
Last 10 minutes for Q&A.
Then let's make 5 minutes for Q&A. Yeah? Okay. Then that was part 3. Then let's go to part 4. That's also a bit quicker. That's looking ahead a bit. What's coming might be coming in the next few months, or what's happening. In case you haven't heard about it, not KD bus. It was IPC, inter-process communication thing developed for the kernel. Actually, it's the developers abandoned this, and they actually started on something else. It's called Bus 1. Actually, LWNet has an article about it, and there was some discussions on the kernel summit, and it's going forward and looking quite good. But it's still work in progress and not yet submitted for official proper review on the mailing list. So it will take some time until it's merged in the kernel. And if you wonder what is different in Bus 1 to KD Bus, its design is a bit more inspired by Android's Binder and other IPC techniques, and it's a bit more universal than KD Bus. It can be used to transport dbus messages, but it can also be used for a whole lot of other things. What else? A lot could be talked about. What the kernel developers are also doing is kernel live patching improvements. You might have heard of it. You can now fix security problems in your kernel while it's running. That only works for 90% of the typical bugs right now. There are some really big changes were prepared, and parts of them are already in the kernel to make it 95 or even a bit more percent of the fixes be able to fix them while the system is running. And these improvements are forthcoming, but it also remains to be seen if they are getting merged next month or maybe in half a year. The kernel is also made secure for year 2038, though some people might know the year 2000 bug. Something similar will happen in the year 2038 for Unix systems, only on 32-bit systems only, but the kernel developers make sure this is addressed and change a few things, because today's hardware, like in your car, there are ARM chips 32 bits that will be used in 2038 because some cars are used for 20 years or something. Support for new hard disk is made. Some kernel developers are looking at making the kernel a bit smaller to make it able to run better on small systems, really small embedded systems. And there are also some improvements to get more out of your CPUs, like for example ARM cores that have eight ARM SoCs that have 8 cores for slower ones and for quicker ones, that the kernel is better able to use the spread the load depending on your current condition to the slow or the quicker cores. But it's also a lot of changes and work, and it's processing quite slowly. That was part 4. Now we're getting to the meta view and look at the kernel development a little bit itself. In case you're compiling your own kernels and not rely on RHEL, Fedora, or your distribution in general, there's a new long-term kernel coming now every January. That makes it more predictable. Long-term kernel means it's supported for 2 years. Makes it more predictable for hardware vendors or distributors to see when will there be a kernel that gets support for not only 3 months, but support for 2 years or even more. The next one, kernel that gets long-term support is 4.9, which I mentioned earlier already. It was recently announced. What else? I mentioned security a few times already. As I said, there are 2 or 3 security issues every week in the kernel. So these days it's pretty much you have to prepare for this, especially because every year there are really a few critical bugs in the kernel that you can use to take over your system. So really be prepared, and don't say, hey, I don't need to update my kernels. It's not that important, because sooner or later attackers will get you. Maybe not on your desktop system, but on your servers. It's really important to make sure all the security bugs in the kernel gets fixed. Big distros know that and they take care of it. Some of the hardware vendors, especially in the embedded space, don't understand that well, and that's slowly becoming a real problem with the Internet of Things. There was this distributed denial of service attacks with video recorders or toys were made together to big botnets that really got to was really annoying for some people that were attacked by this botnet. And as I said, it's video recorders and some other IoT hardware. Hopefully that gets better. GPL enforcement, that's something the kernel developers talked about in the past half year a little bit more. It was a long debate. Some kernel developers didn't like it that much. That was triggered by Christoph Helwig getting to court against VMware. Remains to be seen if what's happening there. Maybe it looks a little bit like things continue as they are. GPL is there and people honor it, but I wouldn't expect a lot of things going to court. What else? The kernel developers noticed that the stable and the long-term kernels are not working as good as expected. Like there are sometimes too many regressions, and the embedded developers or other companies don't use this kernel because they don't know about them. And another example are Android phones running quite old kernels. This is a mess, and it has been like that quite a while. There's no magic no magic thing that can make these things go away, but the kernel developers are talking a bit more to the hardware guys to improve matters a little bit. What else? Testing and regression tracking is a problem. As I said, I did some of that, like compiling lists of bugs and things. And I think that's important because bug reporting for the kernel is hard. You have to basically know where to go to, because on bugzilla.kernel.org it doesn't work well, and on a mailing list there's sometimes not easy, especially if you're not used to mailing list. And this is for example, an area where lots of room for improvements is there. So if you always wanted to do something with the kernel or get involved a bit, there is some area where you can get involved, even if you're not a great programmer, because there's simply help needed by people that know how to talk to others and help inexperienced users to get their bugs fixed. What else? Linux competitors are emerging for IoT. There was Sapphire and Magenta that were a bit smaller than Linux. Maybe Linux is simply too heavy for IoT devices. Maybe the tinification efforts that I mentioned might make things better, but maybe the hardware gets quicker. So Linux is more suitable for IoT devices. And there's always complaints in the media about issues with kernel developments, like kernel developers getting too old, or the tone is too unfriendly, and things like that. I'm looking at the kernel for 10 or 15 years now. It's really complicated and complex topic, and a lot of things are really not that bad as the media makes it sound, and a lot of things are way better than 5 or 10 years ago. But as always, there are something that could be better. So that was part 5, and I fear I'm getting thrown from the stage in 2 or 3 minutes, but we finally get to the end. So, want more details on any of this? Use the web. There's really a lot of sources on anything I mentioned. You can find more things, or maybe ask me. 3 more things quickly. As I said already, testing is something I'm interested in, and I want you to consider helping testing the kernel, especially if you use not that widespread hardware, or maybe quite old hardware, or use your distribution in an unusual way. Because it's simply like that, if you don't test it, nobody might, and the problems get only noticed when they are really, really old. Maybe when the change that introduced the bug was 1 or 2 years old already, and then it's way harder to track them down and fix them. So it's really, if you're doing something unusual or have your exotic hardware, it's in your interest to test and get involved with testing, and to quickly say, hey, something broke between kernel 4.8 and 4.9, because if you're doing that a year later after the change, nobody will be able to help you. One more thing, tell me what you think about this talk or my work in general. There's always something to improve, or if it's really awful, then you have to tell me, otherwise I'm doing it again like this. You don't have to tell me directly. The organizers have a feedback system on the webpage where you can simply give stars. If you want to be kept up to date, you can German. It's likely not that much of interest. LWNS is a better source for you, I guess. It's English, really good topics. And if you want to follow me on Google+, there you can get a glimpse of what's happening in the Linux kernel as well, because I'm posting there about it now and then. That's it. For the curious, that was slide 256. And do we have time for 1 or 2 questions, or only on a hallway? Yeah? Anyone? Don't be... Try it. Otherwise, grab me on the hallway. Did I talk too much and nobody has questions, or did you all sleep? If there really are no questions, then thanks for listening. Enjoy the conference. Yeah.